I'm Glan Thomas. I work with Andrew Hedges at Tapulous / Disney Mobile over in Palo Alto. As Andrew mentioned, I'm originally from London. I came over here to escape the riots. I'm going to go into something a bit more technical, and I'm just focusing on the JavaScript side of mobile application development. In particular, I'm looking at smart asynchronous functions, specifically for mobile. So by asynchronous, we kind of mean Ajax. I'm just favoring the term asynchronous because we're not really doing so much XML these days. It's more like JSON requests rather than the full name of whatever it is, XHTTR. So here's some kind of typical asynchronous functions that you see. Now these are actually based off the jQuery get JSON, get, post. These are quite common in jQuery, Zepto, Prototype. All these high-level libraries offer these functions. And I'm focusing on these because it's kind of a neater way of using asynchronous functionality within an app, rather than having to do the low-level things using the low-level XHR object. So in a modern web app, we're kind of using lots of asynchronous communication. There's stuff where we want to get feeds from the server, and there's stuff where we want to send data back to the server. So asynchronous functions are pretty much the bread and butter. Most modern applications on the desktop will be making heavy use of these. So when we come over to the mobile platform, we kind of run into a kind of couple of problems relying on asynchronous functionality. So first of all, they require an HTTP request. So we actually have to open a connection, send data to the server, and wait for a response back. And as Andrew mentioned in his talk, one of the key things that we're trying to do on mobile is reduce the number of HTTP requests. Not because the request is particularly big, it's the latency on a mobile network. The actual time to send stuff and get stuff back, even if it's a tiny request, could be quite long. So the key thing is we want to minimize these. Secondly, obviously, if we're doing an HTTP request, we actually need a network connection. So this isn't particularly good if you're on like an underground train or somewhere where there's no reception, like my dad's house. You're going to have to be on a network for some things, but it would be good if an app can run and provide some functionality, even if it's not on a network. The other thing that I'll just mention here, but I'm not actually going to cover in the talk at all, is cross-domain origin. So if you're trying to make a XHR request to a server that's on a different domain, they're actually bound by the same domain policy. So it's just something to be aware of if you're trying to make calls to other services. There are plenty of ways to get around it. We're just not going to cover them so much here. So we've got a few objectives that we want to try and build into a kind of JavaScript library, or some JavaScript code that we're building in a web app for mobile. So minimize the HTTP requests. We want to try and make things work so they'll even if the phone is not on a mobile network and has no internet connection. Now, just for application building purposes, one thing that would be nice to have is if we could avoid cluttering up the application or the game's logic with is it online, is it offline conditionals. So we want to kind of keep the controller logic in an application clear of like continuously checking whether things are online and branching in the game logic, because or app logic, because it could be, it's just would complicate things, and it's kind of, we're trying to do a separation of concerns. It shouldn't be concerned of whether it's online or offline. The other thing that's a good thing to do is to try and preserve the original signatures of the APIs that we're using. So if we're using like jQuery or we're using Zepto and we're using this getJSON call, we should always keep it as getJSON. We shouldn't stick a whole load of extra parameters at the end, such as are we caching it? Are we filtering it? Are we keyboard catting it or something? Let's just try and preserve it as it was a get function. Let's keep those other things out of the way. So the things that we can do, so we've got these AJAX functions. What can we do to make them more useful for mobile mobile apps? We can include a cache. So if we've already got that data that we're actually trying to request local, we could just pull it from the cache. And if it's not too out of date, we can use that, rather than actually making an HTTP request and sending it to the server. The other way, if we're actually sending data to the server, rather than actually making the request, if we're offline, we could perhaps add it to a queue and then send it to the server later. Another neat technique might be to actually merge multiple requests into a single request. So actually doing several things at the same time, but from an app point of view, the app thinks it's sending off multiple requests, but we're actually merging it into a single request, sending it, and then getting the response back. A kind of not so big thing, but a good feature could be where if we send a request to the server and then the data that we get back, we actually want to filter and transform in some particular way. So an example of filtering content might be if we're getting a Twitter feed and we actually want to apply a profanity filter. So it doesn't actually reduce any data, it's just cleans it up when it gets back to the client. Another thing that we might want to do is do A/B testing. So where we can send a request to the server and get the same data back, but we can actually present the data in a slightly different way for different users based off some identifier that we have on the client. And then another small feature that could be useful if you've got versioned API endpoints on the server, we can make some kind of decision about which URL to hit, so making sure that the endpoints are always correct without having to go through all the code and update those endpoints within a controller. So I'm going to briefly go over techniques that we can use in JavaScript to help build an app and apply these patterns. So we should look at interfaces. So defining an interface. JavaScript doesn't actually have a concept of an interface, but at least in our minds we should have an idea of what the interface for a particular utility object is. So things like an object that does caching or an object that does queuing, that they have an interface defined of how you actually use those objects, without actually going into the detail of actually how they work. So we're also going to look at using decorators. In fact, everything that I mentioned on the previous web page would be implemented as a decorator around the underlying XHR objects that jQuery and Zepto are giving us. So we're using a decorator pattern to actually augment these functions and provide this additional functionality that we're providing in terms of like caching and queuing. So once we've decorated an object, we use the delegation to these utility objects. So those are the caches and the queues and the filters. There are kind of objects that we're actually delegating that functionality to. So just when we're talking about interfaces, we're just defining how you actually use this object, not exactly how it works. So here we've got a cache interface. It's got a get, set, and delete methods, so you can give it a key and get content out of it. You can give it a key and a value on set and put values into it. So this could be implemented in a kind of number of different technologies. Actually, in JavaScript, it could just be a simple array. It could be local storage, as Andrew demoed earlier. It could even be an SQL-like database. We're not too fussed about how it's implemented as long as it kind of follows this interface pattern. We can also implement a queue. A queue is quite simple. It has you add an item and adds it onto the end of the queue, and then you have remove, and remove pulls things off the front of a queue. So just a kind of little introduction to what a decorator is. We've got something quite plain here. It's a Christmas tree. It doesn't have any decoration on it. You can kind of, it's analogous to our original jQuery get or getJSON function. So we can then bring our decorator. So we have a Pac-Man decorator, and we're going to apply the decorator to the Christmas tree. So we've still got something that kind of looks like a Christmas tree, and it works like a Christmas tree. It has the same signature, but there's something clearly different, and it's been augmented in a very special way here. So that's like our kind of cached jQuery get function. So what just happened? We took the jQuery get function, we applied a cache decorator to it, and then we've got this new object back, or this new function get cached, which we can still use exactly like we were using jQuery get, but we've got this extra augmented functionality in it. So going on to how we might use that in code. It's not as pretty, but this is kind of practically how you might implement it. We're just creating a kind of generic cache object. Again, we're not too fussed about how it works, but it's probably local storage. So then we're taking the standard jQuery or Zepto get function, and what we're doing is we're passing both the jQuery function and the cache object into this cache decorator constructor. And what we're getting out of that is we're getting a new function which has the same signature identity as the jQuery function. So we can give it a URL, and we can give it a success function, and then when that gets executed, it will work very similar to the jQuery function. It's been augmented by the cache decorator, so it kind of changes it slightly, and kind of can make it more useful for mobile. So we can dig down into what the cache decorator is actually doing, and this is kind of a fairly simple chunk of code that's of actually what it's actually doing to the function. I'll leave this up for a bit because it's kind of can be a little complicated. So what we're doing here is we're creating a new function, and it has the same signature as the original function that jQuery has, that has a URL and a success function. I would note that I've simplified it a little bit, but essentially a get function has a URL and a success function that's called when the request is complete with the data. So the first thing that we do is we check to see whether we've got that URL cached. So we're using the URL here as a key on the cache object. So we're checking to see whether we've actually got the data locally, and if we've got the data locally, we fire off the original success function with the data pulled out of cache. We've just given it a little tag to say that we actually did a cache hit and pulled it from the cache. If we don't have the data and we get a cache miss, what we need to do is we need to execute the original function that was passed through. So this is the original function that was passed through when the decorator was created. So it's the jQuery.get function. So we execute that, and then its success function we've augmented slightly with a cache setter in it before we actually apply the original function. So we actually run the jQuery function and then apply save the data that we got back to our cache, and then we return the normal success, or apply the original success function. So one of the neat things that you can do with these decorators is you can actually stack them, so you can actually provide a kind of different levels of functionality all in one go. So here we're introducing a a filter decorator, which could do a profanity filter, it could do any kind of manipulation to the data that we get back from the jQuery request. So what we do is we kind of create our two utility objects. We create a cache, we create a filter, and we take our jQuery get, and then we apply the filter decorator to the jQuery object. So we're doing the filtering first because it kind of really only makes sense to cache post-filtered data. It wouldn't be as efficient if we were to cache data and then have to filter it every time afterwards. So we apply the filter decorator, and then again on that object that we get out the filter decorator, we apply the cache decorator. So then this myGet function that we end up with at the end will actually end up, first of all, checking the cache, and then if it's not in cache, it will go for the filter object, and then if it's not in it will always get filtered, and then it will go back to the jQuery XHR call. So we can have a little dig at the filter decorator. This is pretty simple. What it's doing is we're just augmenting the success function with the with this extra line, data equals filter URL data. So we're just filtering the content there. So I thought the other thing that I did mention at the start, which was the queue decorator. So I kind of promised this, so I thought I'd put a slide up of how a queue decorator might work. Now, this looks pretty simple because the key thing that we're doing is we're actually delegating a lot of the functionality to this queue object, which is kind of mysterious because we only defined a simple interface for it. My idea of the queue is that if we're going to use a queue decorator, everything should go into the queue. So even if we're online, we should still push things in the queue and let the queue deal with the sequence of events. What we do is when things are pushed into the queue, we do fire off a success event. So you'll always get a blank object back saying that it's been queued, but you will also hopefully later on, when the queue's actually dealt with that request, actually get the real success event triggered, or function executed. So I guess the idea of a queue is it should always preserve the order that things are pushed in. So things will always be looked at the head of the queue, and then the XHR request fired off, and then when that request comes back, it's then the callback function is called and the item is removed from the queue, and then the next item in the queue is dealt with. So I've got a few quick takeaways of kind of things that I hope I've covered, and if you guys have any more questions on, please feel free to ask me at the end. So I hope I've explained kind of the idea of using decorators to enhance existing asynchronous functions without altering their signatures. So keeping things, if you're using jQuery.get or jQuery.getJSON, that they're kind of quite okay to use and keep those identities intact, or the signatures of them intact. Then separate the concerns, so delegate things to the utility object. So just have a object that deals primarily with caching or queuing, and if you want to put something in the cache, delegate it to that. Don't, because you'll end up repeating yourself all over your code. So so it's like a good practice of like don't repeat yourself. A good thing if you're using these delegated utility objects is to define interfaces for them. So things for if we wrote a cache object and then we wrote it, say we wrote it in local storage, and then something else new comes along. Say we want to write a version in SQLite, as long as it matches the interface that we've defined, you should just be able to slot that object in, and all of your decorators that use it should carry on working. And then the other point is being able to stack these decorators. So actually you should be able to build a tool chest of like these decorators that will do different things. And you can use them in different orders where it's appropriate in your application. So I did skip a few things. I'll just go over briefly. Cross-domain origin, again, I said that it's not a problem. You could build things to get around that. It's because I mentioned it at the start, I'm mentioning it again at the end that we're not talking about it. Things that could improve things are looking at error and failure states. So I've just dealt with looking at success states. There's a lot that could be explored in terms of having failure callbacks, just to kind of neaten things up. If you're trying to get stuff from cache and you're offline, then you might want to throw a failure event. And there's the same way as if you're actually putting things into the queue and things fail later. I didn't mention too much about the specific implementations. I haven't actually put lots of code up with these, but things you can implement these things in local storage and SQLite or arrays. And then enforcing interfaces, I've just said JavaScript doesn't actually have the concept of interfaces, and I haven't talked about how you can actually physically enforce these, but there's actually in Ross and Dustin's book, Pro JavaScript Patterns, there's actually a good section. Well, it's kind of near the start because they define the interfaces early on in the book and use them throughout. That's kind of a good approach for actually enforcing interfaces if you actually need to in your application. So I'll leave it open to the questions. My slides are up on SlideShare if anyone's keen to download them. Okay, thank you very much, everyone.